Hi everyone, today I will talk to you about VentSim Control. Let's start off by looking at the difference between ventilation on demand and ventilation optimization. So ventilation optimization has many different forms. For example, controlling manually a fan speed, syncing two fans to run at the same speed, having a door open automatically based on gas sensors, or have an airflow regulator opening based on flow measurements, or a scheduling event. And ventilation on demand is a type of ventilation optimization. So what is ventilation on demand? Well, it's an automatic calculation of the airflow demand based on vehicle and personal presence in a zone. How does ventilation on demand work? Using the mine's existing infrastructure, we first get the vehicle and personnel positions, airflow measurements, and gas sensor measurements, send these to VentSim Control, which calculates the air demand and determines the necessary fan and regulator set points, and these are then communicated to the hardware, where the PLCs or remote IOs enable the remote control of equipment such as the fan starters, VFDs, and actuators. So VentSim Control can maximize production by optimizing the gas clearing to get the workers back quicker, and the asset management, which optimizes the fresh air use and gives more capacity and flexibility to the vehicle fleet. Second aspect is improving safety, firstly by improving the air quality, then having a management system for the alarms, logging all system changes, and assuring compliance monitoring for safety regulations. And the third aspect is energy savings. So we have an optimization where we can reduce any wasted airflow while still meeting the airflow needs, which then reduces the energy consumed by the fans. We also have advanced controls where we optimize the operation of fans and regulators, which gives energy savings between 10 and 50%. Additional cost savings are peak electricity or heating and cooling reduction based on airflow need reduction at the inlet. Let's look at the 5 levels of control. So level 1 is manual remote control. Level 2 is automatic scheduling control. Level 3 is automatic flow control based on flow monitoring, as well as gas sensor integration. Level 4 is ventilation on demand based on the tracking integration. And level 5 is optimization algorithms such as speed optimizer, total demand, or custom controls. Now let's have a look at the VentSim Control software. So here we have the summary page of VentSim Control, where we can see all of the controllers that are configured and their mode and their state that they're in at the present time. You can also click on the controllers to access the faceplate to be able to change the mode they're in and the operating condition. Another way to visualize the ventilation system data is through the 3D viewer. So here we can see the VentSim design model that has been imported, and it's actually running the simulation in parallel with the real world information. So the black boxes show the real world fan and regulator openings and control set points, and then the simulation data in the background is associated to those set points. So we can run a simulation environment, so we can have an engineering station that runs the mine model ahead of time, so you can plan for the future control needs. And then when you're in live control, then you can control directly from the 3D as well. So we can access the controllers directly from the 3D. Another way to visualize the ventilation data is through the level plans. So click here and import the drawings of the level plans and superimpose the controllers, and then you can see all of the operating modes and flow measurements and set points at the same time. Okay, all of this is done through a configuration process. So we can define all of the users that will be configured with different access rights. And for each controller, you basically have a choice of selecting or enabling different functionalities depending on your control needs. So there's no programming involved. It's really all done through a configuration process. An example of some reports you can generate is the energy report, which gives you the energy cost of the current operating status of the fans, or you can also create an archive report between two periods of time. Let me give you an example of the 5 levels of control. So level 1 is manual control, so you can change the speed from 75 to 50%, for example. Now we can see an alarm that has been configured in the system, which you can click here to acknowledge, and once the alarm condition has been removed, then the alarm disappears. Level 2 is scheduling. So here we have an event that only affects this fan controller. You can see the configuration here, where we're affecting only the L30 auxiliary fan, manual mode 70%. So you can schedule this in time with a recurrence, or you can just start it immediately, and you can see that the scheduling changes automatically that fan speed from 75 to 70%. Okay. Level 3 is flow control, so changing from manual to flow. You can change the flow set point, for example, to 25, and then the PID gains automatically adjust the fan speed to attain that 25 meters cubed per second set point. There's another example of flow control with a bias, where we have a sensor that is measuring the CO. It's currently measuring 10 ppm with a 9 set point, and this will automatically increase the airflow in that zone by eliminating the CO gases. Okay, and then level 4 is the ventilation on demand based on the tracking system. So here we have the associated tracking demand that is usually fed by the tracking system. So it could be Ekahau, Nutrax, or Our Scout, for example. And based on the configuration, we have one truck here that is providing 20 meters cubed per second demand, and we can see that in the controller over here. So when I switch over from flow to VOD mode, then we can see that this 20 meters cubed per second is now the set point for that controller. Control level 5 is an optimization level. So for example, here we have a fan speed optimizer setup, where one fan is exhausting from 4 parallel regulators. Each of the regulators has its own VOD or flow mode. That is, its main purpose is to attain its flow set point or demand. And the fan here is presently in manual mode at 100%, so it's not optimized. So when we set this one to fan speed optimizer, it's configured to look at the maximum regulator opening and have it attain, for example, 80% to relieve the restriction in the system, and then that automatically decreases the fan speed to an optimal energy setting. Now let's have a quick look at the software-hardware integration. So for VOD hardware implementation, there are 2 options. Either using the mine's existing hardware, such as Nickel South or Eleanor examples we'll give shortly, or using the Howden VentSim hardware, such as Dougal River or San Julian Mine. There are some advantages of using Howden VentSim hardware. They're off-the-shelf products which provide simplicity and compatibility, and the VentSim Control software provides the full capability over the hardware. The configurations are easily backed up and restored very quickly. The kits are pre-assembled before shipment, which reduces installation time on site, and there is no programming required. The requirements to install on site are a communication network, which can be Wi-Fi, Ethernet, or LTE, having automation, PLCs, remote IOs, or the Howden hardware. Software license based on the control level and number of devices you're controlling. 2 servers, a control and an HMI server, which could also be virtual servers. And training, either at Howden or on-site. Additional on-site options are system configuration can be done by us, or we train you to do that. The same thing for the system commissioning. Then there's software maintenance to have the latest version of the software. And there's remote or on-site support. Now let's look at some case studies to have some real-world examples. First example is the Fresnillo San Julian mine, which has all 5 levels of control, controlling 15 primary fans and 12 airflow regulators, and all of the associated flow temperature and gas monitoring. They're saving approximately $200,000 US per year. The Glencore Nickel Rim South mine has all 5 levels of control. They're controlling 5 primary fans, 199 auxiliary fans, 21 airflow regulators, and all the associated monitoring. And their main justification was to be able to manage the vehicle fleet properly and get the energy savings, which we can see an example here. They have between $2.5 and $5 million of savings per year. We can see the breakdown of the fans, energy savings, as well as the heating savings based on airflow reductions, and the peak energy savings as well. Another example is the Newmont Eleanor mine, which has 5 levels of control, controlling 6 primary fans, 240 auxiliary fans, 41 airflow regulators, all of the associated monitoring of flows, temperatures, gases. They have 196 vehicles that have RFID tracking, and they have significant energy savings between $4.5 and $6 million per year. And last year they were awarded the Eureka Prize from the government for innovation with their ventilation on demand system. Another example is the MMG Dougal River mine, which has 3 levels of control, controlling 22 auxiliary fans, 24 airflow regulators, all the associated monitoring, and Howden provided all of the automation panels and the automated regulators as well. An example is Fresnillo Saucito mine. They have 3 levels of control, controlling 20 primary fans, 3 airflow regulators, and we also supplied the hardware connection kits for this project. Another example is the Fresnillo La Cienega mine. They have 3 levels of control, controlling 4 primary fans, 2 airflow regulators, 1 door, all of the associated monitoring, and Howden also supplied the hardware connection kits. Barry Cortez mine has 2 levels of control, controlling 3 primary fans, which was installed just last year. Fresnillo mine has 2 levels of control as well, controlling 10 primary fans and the monitoring associated to that. Howden supplied the hardware kits in this case as well. And then there's the Glencore Fraser mine, which has 2 levels of control as well, where we're controlling 107 automated fans. As a summary, with VentSim Control, you can increase production by managing the assets. You can reduce the energy by reducing the fans' energy needs, the heating, cooling requirements, and peak electricity. Improve safety by improving the air quality. You can plan ahead for the mine's live ventilation needs. You can log and trend important data. And now you can take control with the SCADA for real-time control and optimization. Thank you for watching, and if you have any questions, don't hesitate to contact us at ventsim@howden.com. Thank you.